RealAgriculture.com presents Farming Forward. Sharpen your soil health expertise with cover cropping, nitrogen management, and advanced grazing. Brought to you by the Farm Resilience Mentorship Program.
Hi, I'm Bernard Tobin. Welcome to Farming Forward. Today we're heading to Bisbee, Alberta for another visit with rancher Steve Kenyon. On this episode, Steve takes us underground for a look at his soil profile and shares how advanced grazing has helped him build soil, sink carbon, and increase water holding capacity. Check it out.
We do an advanced grazing system here. We rotate cattle around. I use the cattle as a tool to manage the forage. And that's kind of a mindset shift that a lot of people don't have, or that maybe a lot of people need to get past. The cattle aren't here to manage the cattle, right? I'm using them as a tool to manage the grass, which in there helps me grow soil. Because we don't start with any topsoil. This field here we've had for about 20 years. This is a gray wooded soil. Basically this used to be all trees. And when you wipe out the trees, you basically start with no topsoil. So even when we took this over, it was a pasture, but there was hardly anything growing. It was severely overgrazed and virtually no topsoil here. There was just some grass growing. So over the last 20 years, we've grown a lot of topsoil. We've got on average probably somewhere between 8 and 12 inches of topsoil on here now. And it's not that we're growing above ground. What we're doing is converting the base. So we've got a very clay base. So we've been adding carbon into that clay for 20 years. And now we've got, 8 to 12 inches of black topsoil. And we're going to show you the soil profile and how we've built that up. So what we're looking at here, we've got, green plant material, lots of root systems going through a thatch layer right about to there. We got good root systems under here. A good healthy soil clumps together. They say it looks like cottage cheese. So we've got good clumpy soil. The roots are holding this all together really well. And now the roots are going down into this clay, right? We have a very clay-based soil. It's going down and we're adding carbon. See how the different color? Now down here we're clay, right? That's the typical clay color. But now we've added carbon into that. That's still very clay, but look at how black it is, right? We're creating topsoil in the clay, right? Those roots are going down and causing that. So we've got a layer right about there is where our layer is. So that is probably, 8 to 9 inches, 10 inches of black topsoil in a gray wooded soil zone.
And how long did it take you to create that 12 to 18 inches?
Yeah, we took over this pasture about 20 years ago. So first couple of years were severe droughts, 202 and 203. I remember those years quite vividly. But about, I would say 20 years total, right? We've got to accommodate for the droughts either way. But yeah, we're right about there.
Your water retention capacity is like that. I just think of that when I see this.
Yeah, I mean, every an inch of topsoil holds something like 27,200 gallons of water. Every inch of topsoil that I have on here. So how much water is that for a season? Building an effective water cycle is one of the top priorities on my ranch. Getting this thatch layer, not having bare soil, allows the moisture to soak in, and getting the organic matter down here holds on to it. But you can also get too much water in there if you get lots of rain. We want it to be able to infiltrate. Okay, we had we were testing for compaction out here with a penetrometer, and you'll see when we do some soil samples here how easy that we can penetrate into this ground. So the penetrometer is just a big spike. It's about 3 feet long, and when you push it into the ground, you're supposed to stop it when it gets to 300 psi, and that'll tell you your compaction. Because anything over 300 psi, they figure that root systems have trouble getting through. So a very compacted soil, the roots can't penetrate through. Well, the penetrometer is 3 feet long, and we buried it to the hilt every time. Okay, so this is a soil sampler. We talked a little while ago about the penetrometer and how you can sink that into this ground because our compaction is very low. We've had root systems that are opening up this soil for years, and so it makes it pretty easy to use that penetrometer. Just with a soil sampler, this is about 1/2 inch in diameter. Just sinks down, right? It doesn't take very much to get it in there. The first little bit of layer is usually tougher to get through, that thatch layer, but once we get into this, it's really easy. So here's our thatch layer, here's our topsoil, probably down to right about here, and there's our clay. So in this spot, we're about, what, 8 inches? 6 inches, 6 to 8 inches there. Okay, and then we can pull that out. You can see the core, right? That's just black topsoil in a gray wooded soil zone. And we're starting to change, right? We're a little bit lighter. And then we go a little bit more here. Now we're getting into clay. Now it's getting sticky because it's clay. Right now you can see here it's pretty well all clay now. Okay, but there's some places that like we're kind of up on a hill here. If we went down over there a little bit, would be easily 12 inches.
So Steve, academia talks about 100 years. You've had this result in 20. Based on your practices you're engaged in now, can this layer of topsoil get even larger?
I would say yes, for sure. It'll slow down. I mean, I was talking to Dr. Bork at the University of Alberta, and he said that we were trying to convince another group that this would be a good idea for them to start. And they said, well, how fast can this improve? He said, well, depends what you're starting with. If I'm starting with Steve's land, it's going to be slow. But I'm starting from anywhere else, we can do this relatively quickly. Right? So yes, we're 12 inches, 8 inches, whatever, somewhere in there. I'm going to go deeper, right? And if I'm only at 8% right now, well, I've got another piece of land that I'm already at 11%, right? So I don't think there's any end to this, right? As this gets bigger, as this gets deeper, we're going to get more water holding capacity. We're going to get deeper root systems, and we're just going to go deeper. So you know what? I'm hoping someday, maybe when the next generation is still working on this, we're 3 feet deep.
So, what's the why on that? Like, to what end? What if it was 3 feet? What's the benefit?
Sustainability, right? The mission statement of Greener Pastures Ranching is economic and environmental sustainability for generations. Okay, we're not thinking 10 years from now. I'm thinking 100 years from now. Okay, is this going to be sustainable? This will. Let's use that phrase that everybody uses. This can feed the world 100 years from now, right? If this is all depleted, it can't. We need to have this organic matter, this topsoil, to be able to continually grow forage so that we can, continually to graze and produce a very nutritious food source.
Earlier we were chatting about the fact that a lot of people focus on what's happening above the ground, whereas you're focused on what's happening below the soil profile. Talk about the role that plays, that change of mindset.
Yeah, I believe there's a mirror at the soil surface, right? Whatever's happening above ground, there's also a replica going below ground. Okay, so when I'm grazing this pasture, I'm not actually thinking about the top of the plants, right? I'm thinking about, okay, what are the roots doing? What shape are the roots in? You don't want it to have the plants take a second bite is a very, very important point. I talk about it like pretend there's a fuel tank under there, right? There's an energy reserve in the root systems of these perennials. Okay, there's energy in there. If we come along and graze the top, take it off, if we take it severely down, it's going to need some kind of energy to regrow. Okay, if there's no green matter, you can't get energy from the sun, so it uses up its fuel tank. Okay? And it'll use that up, put up a couple new shoots. Now, if at that point the cattle are still out here and they graze those new shoots, that's called the second bite. Well, we knock away their ability to capture sunlight, we've emptied the fuel tank, that's when overgrazing occurs. That's it. It's simple. That's overgrazing. So we need to manage the herd to stop the second bite. Okay? That can happen if your graze period's too long, so your cows are still out there and they're taking that second bite. Or it can happen if your rest period's too short. So let's say we grazed this down, moved the cows off, they grazed away, but we brought them back before the plants have fully recovered. Well, we still have green plant material, empty root reserves, they graze that off, it's still overgrazing. Okay? So that second bite is crucial in this. And allowing those plants to grow up fully again, fully recover, also means those roots went down fully and pushed out exudate the whole time. In my environment, if I can do that twice or maybe even on some paddocks 3 times in a season, we get 3 times the exudate pushed out. So we can grow that soil that much faster. If I just let it grow once and graze it, you know, the whole time, the roots never get to penetrate down because the cattle are always grazing it off. The roots, we talk about sod-bound forage. Well, it's because the roots never got to dig down, right? We're digging down. Some of these root systems here are going 4, 5, 6 feet down, right? We've got root systems way down here that are penetrating down. So we got root systems coming out. There's a root right there. There's a big root. That one's dried, but all these little root systems.
You're almost
look
2
at that.
feet down there.
Yeah, and we can probably go further. If you want to look over here, look at this alfalfa root. We hooked it with the hose, so we broke it off, but imagine how deep that one went. Okay, so we got roots going down really, really deep in here. There's roots hanging off. There's roots right there. There's a root. So we got root systems. There's even one right down there coming out.
Way down there.
Yeah. So yeah, the farther down we can reach with root systems, the more carbon we're going to put down. Really interesting fact here too, the soil test that we just got back from this field in the back, our top layer, so they did 0 to 6 inches and they did 6 to 12 inches. They did those samples. So, and you could see it in the soil probe, the top layer was actually not as dark as the bottom layer. So we had more carbon in this layer than we had in this layer. Now, I'm not sure why or how. I'm asking a lot of the soil scientists why that's happening. But very interesting. The average was still about 7%. But yeah, normally you would expect the top layer to have more, but and the bottom layer to have less. But there's still some carbon going down here, right? We're still getting some down here with those root systems. But yeah, we're just going deeper. That's the goal.
If you enjoyed this video and want to continue to sharpen your soil health expertise, encourage you to go to farmlearninghub.ca to learn more.